Welcome back for a new session. During operation of a tunnel boring machine, we have to overcome many challenges. Sometimes the ground stops behaving. Deep underground, where pressure, water, clay, sand, and rock fight against the machine, one invisible process decides success or disaster. That is soil conditioning, the science of converting unstable earth into a controllable material. In this video, we will understand how EPB TBMs survive underground challenges using foam, polymer, pressure, and experience. An EPB TBM works by balancing the pressure at the tunnel face using excavated soil itself. But natural soil is unpredictable. Sometimes it is dry sand, sometimes sticky clay, sometimes flowing silt mixed with groundwater. Raw excavated material cannot always maintain pressure properly. So engineers modify the soil behavior. This process is called soil conditioning. Today we will discuss in a detailed manner. As a general understanding, soil conditioning means injecting materials like foam, bentonite, and water into the excavation chamber to transform the excavated soil into a plastic-controlled material. The conditioned muck should flow smoothly and hold pressure. It should prevent collapse, reduce wear, and avoid settlement. A properly conditioned muck behaves like toothpaste. Not too dry, not too liquid, just stable enough to carry pressure safely. Without proper conditioning, chamber pressure fluctuates and screw conveyors block. Surface settlement can develop. In urban tunneling, poor conditioning can damage buildings above ground. In extreme cases, situations arise to abandon an entire TBM drive. We use foam as the primary conditioning agent in EPB tunneling because foam reduces friction and improves plasticity. It also lowers permeability, helping the chamber retain pressure. Now let us understand FER. FER means foam expansion ratio. It tells us how much foam is generated from 1 unit of liquid solution. FER equals foam volume divided by liquid volume. If 1 liter of foaming solution generates 15 liters of foam, then FER is 15. That means the foam has expanded 15 times. Low FER results in wet, heavy foam, while high FER creates dry, light foam. FER basically controls the quality of foam. Now comes FIR. FIR means foam injection ratio. This tells us how much foam is injected into the excavated soil. FIR equals volume of foam injected divided by excavated soil volume. If 5 cubic meters of foam is injected into 10 cubic meters of soil, the FIR is 50%. We can summarize that FIR controls the quantity of foam entering the ground. Simple trick to remember, FER equals foam quality, FIR equals foam quantity. FER controls how the foam behaves, FIR controls how the soil behaves. If FER and FIR are incorrect, several site problems start immediately. Case 1, low FIR, the soil becomes stiff, causing screw conveyor choking, high cutter head torque, and face instability. Case 2, excessive FIR. This leads to overconditioned muck, slurry-like flow, loss of chamber pressure, and surface settlement risk. Case 3, wrong FER. The foam collapses quickly, leading to poor conditioning and uneven muck properties. As a thumb rule, typical industry values are FER between 10 and 30 and FIR between 20% and 80%. But remember, there is no universal value. Everything depends on soil type, moisture, permeability, fines content, and groundwater. Always observe screw conveyor discharge visually. Perfect conditioned muck should look like plastic toothpaste. If muck becomes watery, reduce FIR immediately. Continuously monitor torque, thrust, screw current, and chamber pressure. Finally, never blindly copy conditioning parameters from previous drives. Modern tunneling is not only about steel machines, it is about understanding the behavior of soil under pressure. The best TBM operators are ground behavior specialists, and underground soil conditioning becomes the difference between success and disaster. If you want more real TBM engineering knowledge and practical tunneling lessons, subscribe to the channel.